The question says the given complex ion is diamagnetic, paramagnetic, square, planar, or none of this. Whenever the question is related to hybridization or geometry, always use valence bond theory. Okay. To apply the valence bond theory, we follow the order. First, you write the oxidation number of the central metal atom. Okay, central metal atom. Next, we write electronic configuration of central metal ion. Then we write orbital notation, orbital notation, and then we have to consider effect of ligand, whether we have a strong field ligand or weak field ligand. Okay, if strong field ligand is there, pairing of electron, weak field ligand, no pairing of electron. Okay, we follow Hund's rule in case of weak field ligand. Okay, the first step we have to calculate the oxidation number of central metal atom. Okay, this is the complex. We have a Cr. This is a neutral ligands. Ammonia, it does not carry any charge, then it has 0 charge. And overall charge is what? Plus 3. Then Cr is present in plus 3 oxidation number. Okay, we got Cr plus 3. For this we have to write electronic configuration. Chromium having atomic number 24, outermost electronic configuration 3d, 5, 4, S1 is there, and it is losing how many electrons? 3 electrons. Then Cr, let me write this side, we have Cr3 plus, will have electronic configuration losing 3 electron, it will be 3d, and it is going to be 3d3. Okay, 3d3 is there. Now we have next orbital notation. Let's write orbital notation. Cr3 plus is there. First we have d orbital, 3d3, then we have 4s orbital, then we have 4p orbital. Okay, sorry, it is supposed to have 4p, and then we have 4d orbital is there. 4d orbital. These all are vacant orbitals. Okay, 3 electrons are there. Before filling these electrons, we consider the effect of ligand, whether strong field ligand or weak field ligand. You can see we have the ligand. What is the ligand? So you can see ammonia is there. Ammonia. In general, ammonia acts as a strong field ligand. And ammonia acts as a strong field ligand with the elements. We have cobalt, iron, copper, and cadmium. Ammonia acts as a strong field ligand only with these metals. Okay, ammonia acts as a strong field ligand only with these metals: cobalt, iron, copper, and cadmium. Okay, with remaining metals it will be acting as a weak field ligand. So you can see chromium is not coming in these metals, then ammonia is acting as a weak field ligand in this complex. And weak field ligand means no pairing of electron. We can fill 3 electrons. We have a first electron, second electron, and third electron. Since we consider it as a weak field ligand, though no pairing of electron is there. Now how many ligands are there? Total 6. Then we need to use 6 vacant orbitals. This is the first orbital, second orbital, third orbital, fourth orbital, fifth orbital, and this is the sixth orbital. Okay, now you can see how many orbitals are participating in the hybridization. We have D2s, and it is what? P3. D2s P3 is there. If D2s P3 is there, this will form octahedral geometry. Octahedral geometry. You can see geometry, we have only square planar is there, so that is not possible. Okay. Next, if we talk about whether it is paramagnetic or diamagnetic, you can see central metal atom is having unpaired electrons. Obviously, it is paramagnetic by nature. Okay, species having unpaired electrons will be paramagnetic, and having paired electrons will be diamagnetic by nature. Option C is correct. If you like this video, please share and subscribe to the channel.